So these equations can be quite tough. Let's take a look at one. T equals 2 pi times L over G. And your task is to solve for G. Solve for G. All right. So the steps here, it's a little difficult, but you want to think what is most indirectly being applied to G. So G appears to be in a fraction. That's probably the last thing I'm going to take apart. It appears you take the square root of that fraction, so that'll be like the second to last thing I take apart. So I'd like to go as far away from the variable as possible. So if I'm solving for G, I'm actually going to start right here with this 2 pi. So the first thing I'm going to do is I'm going to move 2 pi to this side. So I need to think, what's the relationship between 2 pi and the rest of the side? Well, the relationship is multiplication. This is 2 pi times the square root of L over G. So if I'm going to move it to the left side, I'm going to divide both sides by 2 pi. All right, and that leaves me with the square root of L over G. Now, I have G. I'm closer to having G by itself. It's being divided into L, but overall, the whole thing is taking a square root. So inverse operations, I'm going to square T over 2 pi squared equals L over G. Now, this part can be a little confusing. To solve for G right here, I can't really get rid of this L. If I divide by L, well, I'll end up having 1 over G, not G by itself. So G would have to be in the numerator for me to have it by itself. So what I'm going to do is something a little weird, but I'm going to multiply both sides by G. Kind of weird because you're thinking I'm going to get G by itself, and you will eventually, but it's not going to be by itself on the right side. So that'll cancel out your G's right here. And you're left with G times T over 2 pi quantity squared equals L. And if you would have been asked to solve for L, you would have been done. But it asks you to solve for G. So now what you need to do in turn is, because this says G times a quantity, you just need to divide by that whole quantity and you're done. So G equals L divided by the quantity T over 2 pi squared. That's your final answer for that one. Same for this one. This formula says T equals 1 divided by F, and you're asked to solve for F. So again, you can't really undo the 1. F is being divided. It's not having something divided into it. So key thing to look for, if the variable you're trying to solve for is in the denominator, you're going to need 2 steps. So I am going to start by multiplying both sides by F, which is going to cancel it on this side. So I have F times T equals 1. And now I can divide both sides by T. So I get F equals 1 over T. And that's my final answer. Last, I have here a problem where I'm trying to solve for R. All right. Notice how once again the variable I'm trying to solve for is in the denominator. So I'm going to apply the same thing I've done in the past 2 problems. I'm going to multiply both sides by that denominator. So it cancels it out on the right side. And on the left side, I have R squared times FG. FG is just a single variable. It just has a subscript, all right, to show that it's, I believe, gravitational force, all right? M1, M2, just like M1 and M2. They're not the same variable, okay? Now, if I'm going to solve for R, I need to get rid of FG. So R squared equals G M1 M2 divided by FG, right? And I divided by FG because FG is being multiplied to R squared. Now I just got to get rid of my squared. So I take the square root of both sides, and R is equal to the square root of G M1 M2 all divided by FG, all right? And all of that is under the radical. Okay, bonus problem. So if you have a fraction, here's the best way of dividing a fraction out. So instead of dividing both sides by 1/2, you can multiply both sides by 2. All right, so this is 2a equals h times b1 plus b2. You're solving for b2, so you're going to divide both sides by h. All right, that's because this is h times that quantity. And then last subtracted by b1. Okay, so